Is it possible to get rid of excess CO2 by storing it deep in the seabed? And what would be the effect on ecosystems if this practice was widely used? A European research project is trying to answer these questions. In idyllic waters of Italy's Aeolian Islands, researchers are studying the possibilities of carbon capture and storage, or CCS. Their goal is to make a significant contribution to reducing the greenhouse gases causing global warming.
The idea is to prevent CO2 from coal-fired power plants and other facilities reaching the atmosphere, because that accelerates climate change. We want to prevent that. So we separate it and then we have to store it underground in geological formations. You can do that onshore or offshore, which is better.
The scientists working off the Aeolian Islands are trying to figure out what happens when carbon dioxide leaks into the sea from the seabed. This archipelago was formed by volcanoes. There are big quantities of natural deposits of CO2, making it an ideal research site.
Around here, there are organisms that have been adapted to this environment for a long time. This is an area where the CO2 escapes naturally, an area where, therefore, the pH is usually lower than in other areas.
Chasing bubbles is a key part of the research. To analyze the dynamics of the gas, the scientists need to observe the behavior of the endless stream of bubbles rising from the seabed. In addition to becoming accomplished divers, they've created very specialized equipment.
We've developed a bubble box to measure the size of the bubbles. We illuminate the bubble from the background. That makes it easier to measure in the computer later. That's important for our numeric models.
Another way of visualizing the CO2 is through the observation of pH levels in the marine environment. Studying the movement of the outflow allows the researchers to develop a model that can monitor the venting gas and predict its dispersal.
The dissolved CO2 causes a change in pH. This is what we're looking at to see how that moves throughout the seasons, to see the best places that this could be detected.
To analyze the behavior of this gas elsewhere in deep sea abysses, the research technology has had to be adapted. CO2 has been stored in the seabed in the North Sea for years in reservoirs from which oil has been extracted. The new technology assesses the risk of leaks and what the possible consequences would be if they occurred.
We let a limited amount of CO2 escape from the machine. We then surveyed that with our sensors and tried to follow the footprint in the water. It's extremely important to incorporate this data into our models in order to make forecasts.
The physical conditions of the North Sea are recreated at a laboratory in Kiel in Germany. The goal is to define a digital model that works for leaks on a small and large scale.
We investigate the reactions CO2 causes as it rises. The next step is about grain size, how the gas travels through the sediment pores. Then we need to understand how all that works macroscopically on a scale of tens or hundreds of litres. We deduce information from these experiments and from the different scales into mathematical formulae.
The research has some way to go, but scientists believe worthwhile conclusions will come to the surface.